मैं साइड पे रहता हूँ अभी जो है ना
स्टार्ट करने
अभी 2 मिनट बाद ये टाइम देखिए ना 31-32
Good afternoon, all participants, organizing members, and keynote speaker. Uh, Dr. Chavi Rana, from the Department of Computer Science Engineering, UIT MG Rohtak, welcome you to the 6th session of AICTE-ATAL sponsored FDP on 3D printing and design. I hope you are enjoying FDP. Now, let me introduce our speaker, Dr. Imran Siraj, who is going to talk about design quality issues in 3D printing. Let me introduce Dr. Siraj. He is an assistant professor of mechanical engineering at St. Andrews Institute of Technology and Management, Gurugram. His interest fields are robotics and mechatronics. He has experience of more than 10 years in the field of manufacturing of precise automated components and fabricated components of automobiles and equipment manufacturing. I request all participants to keep the audio and cameras off. If you have any queries, put them in the chat box only. We will discuss all doubts at the end of the session. I welcome Dr. Suraj to continue the session.
Thank you, ma'am. Hello and welcome to everyone. I am Imran Siraj, and in this FDP, I will discuss the quality issues that arise in the 3D printing. I hope my screen is clear to you, my screen is visible to you, because once I share the screen in Google Meet, it gets started hanging. So I suppose it's now clear to you.
It's
Okay.
clear, sir.
Okay. So I will discuss the quality issues that we are facing in 3D printing. But before starting, what are the quality issues and how to address them, and what is the future of 3D printing as far as Indian industry is concerned, I would take upon certain surveys and financial reports that has been released by key controllers and key financial auditors. In this year 2020, projected growth by reliable financial reports and surveys about 3D printing technologies. Uh, McKinsey Global Institute is one of the best research institute in the field of financial analysis, and they have indicated that by the year 2025, that means within 5 years, the economic impact of 3D printing could be US dollar 200 to 500 billions annually. They are giants, and whatever they say is more close to reality. Then I'm coming to another market survey that has been done by Markets and Markets Research Associate. They also say that the market of 3D printing is expected to reach by 32.78 billions within 3 years by now. So one thing I would like to clear that these reports and surveys were taken and were published before the COVID-19. So exactly, I'm not. It is the impact of the COVID on these on the research of on these 3D printing market is not clear. But I am taking the data before the COVID-19. So all these surveys predict a high value of 3D printing and a good market share of 3D printing technologies. Then we have a Technavio that is also predicted that in the next year, by the end of the next year, we would be having compounded annual growth rate of more than 35% by the end of the next year. Then we have another surveys, and this is one done by Deloitte Analysis. They have predicted by the end of 2017, that means 3 years back, they predicted that the net worth of the 3D printing market would be about US dollar 3.1 billions. So they started analyzing the market from the 2014, and then it started by a US dollar of 1.8 billion, and by the end of the 2020 they are expecting that it will be around 3.1 billions. That means percentage increase would be about 12.5%. And every year they mapped in this bar chart, and they started from the base year, assuming the base year 2014 at 1.8 billion asset of this 3D printing market. Then it came to 1.9, then 2.2 billions, 2.4 billions, 2.7, and ultimately it is 3.1 billion. But again, this report was out before the COVID. So still the impact of the COVID are not known. So by the process we are going, and many other researchers are going to correctly calibrate the impact of COVID and the 3D printing technologies also. As all the financial analysts are doing, we are also doing our best to find the impact of this financial status of on COVID-19 on these markets. Okay, so this is the Deloitte analysis research. Then we are coming to another giant, Fortune Business Insight. That they say in their report that 3D printing market size, share, and industry analysis, the value of the market stood by US dollar 8.58 billion in the year 2018. They evaluated the all components related with the 3D printing. They calculated took the stock of hardware, software, and services. Then by technologies, they simulated all the technologies. They evaluated all the technologies: FDM, SLS, stereolithography, and then direct metal laser sintering, and then polyjet, multi-polyjet, then digital light processing, binder jetting, EBM, continuous liquid interface production, and SDL, and laminated object manufacturing. So they calculated and they accumulated all the activities that are associated with these and the finance activities that are associated with these technologies, and they clubbed that it would be around 8.5 it was around 8.58 billion in 2018. Again, they also calculated all the applications that are related with the 3D printing and by the end user. So the parts, the components that are being made by 3D printing in automotive and aerospace and defense, healthcare, and all other sectors. It was estimated that the impact of 3D printing, or the money involved in the 3D printing globally was 8.58 billion in the year 2018. Sorry. Again, coming to some other reliable sources, another 3D printing market outlook. So now the predictions are for the 5 years, for next 5 years. So you can see we started from 1.8 billion in the year 2014, and now this is year 2020. And by the next 5 years, we are expected to reach 8.58 billion US dollars. The whole market scenario would be close to $8.58 billion. So this was 3D printing market size, share, and industry analysis, Fortune Business Insights trademark report. They also a giant of this field, and their reports are very much reliable and close to the realities. So they are also saying that 8.58 billion is the market value, and then by the year 2015, we would be having around $44,391.1 millions. So that is, we are predicting by the year 2025, we would be having this much of amount involved for all the 3D printing activities. Okay. So also they told that North America was the highest contributor to the global 3D printing market with a net worth of $1,728.1 million in 2014, and estimated to reach $16,838.3 million by their within 5 years, registering a compounded annual growth rate of 20.8% during the forecast period. So these were the reliable analysis and surveys globally that are depicted in these figures, and we can see how the global market has responded to the 3D printing technologies. So we started from this 14.5 US million dollars, US dollars in millions, and from there we reached on to total 100.4 billions. So this way we can also to 2015 to 20, and then for the next 5 years we have predicted that we can reach up to 100.4 US dollars MRO spent. Then we have market share. Market share forecast was 22% earlier from the 2015, then 2019 it is 19%, then 2000 it is projected that by the 2025 we will have a market share airframe engine component line So this was the market share forecast by MRO segment. Then we have compounded annual growth rate between 2016 to 2021. So this is the cumulative compounded growth rate, that is 36%, 36.89 to 37.29, 37.06 and 38.25. And this is the market share: 12.8%, 14.7%, 16.23%, 18.49%, 21.5% and 16.9%. This is automotive, consumer product, healthcare, aerospace and defense, industrial and other. Here I would like to mention this data: 12.8 for the industrial sector. For application of the 3D printing in industrial sector is, we can see that, quite low, and that I'd be discussing today. So when coming to Indian context, we have Indian Brand Equity Foundation, IBEF, and in their report published in 2018, they have told about the manufacturing sector in India, that they have told that 3D printing technologies that literally took us over the moon is yet to create a firm footing in the Indian industry. This technology is still not as widely spread and penetrated as we would ideally like it to be. The attention that this technology has garnered is not congruent with the adoption ratio, which can be more encouraging. However, its popularity is increasing day by day, and with that, its application and adoption in the industry will grow exponentially. So this is the report about Indian Brand Equity Foundation, the most reliable source of financial inclusion and financial calculations as far as Indian market is concerned. Now, another research analysis wing, 6W Research, they are also concerned, they are also related with the financial status of all the sectors in India, and they have also told that by the 2021, in their report, they have indicated that the 3D printing market is India estimated to touch by $79 million by 2021. With the focus on optimizing cost and quality of production, shorter development cycle times, adopting engineering and manufacturing approaches. They have also, 6W Research have also again indicated that 3D printing is yet to become a natural choice for the industries to invest in to retain their competitive edge. I have highlighted this whole sentence, and this whole sentence is going to be pretext of my talk. 3D printing is yet to become a natural choice for the industry to invest in to retain their competitive edge. This will increase the penetration of this technology across various industry verticals. So currently, the use of 3D printing in India is restricted to conventional applications such as prototyping for visualization and validation in the industries such as consumer products, automotives, and aerospace. However, with great awareness of the technology and its benefits, it is now being considered for use as an alternative technique for customized small batch productions and manufacturing tools. I would also reiterate on the last sentence in this paragraph, that it is now being considered for use as an alternative technique for customized small batch productions and manufacturing tools. Let's talk more about the introduction, then we'll be coming to the final body. As far as Indian market is concerned, 3D printing presently is being widely used by the medical industry in India. However, the advantages of using this technology in other fields cannot be ignored nor overlooked. They are apparent and imperative. 3D printed parts are robust in strength, faster to develop and easier to modify as the technology becomes affordable. The medical devices industry has largely adopted 3D printing to lower their cost of product design and development, while still building reliable devices. However, the medical community consisting of doctors, paramedicals have not yet forthcoming to use it for developing implants or for mock surgeries, etc. It is a proven technology of which the Indian medical community has started taking cognizance of, and we will soon see this becoming a vital part of this decision-making process. 3D printing in India will further pave its entry into other segments such as arts and design, interior decorations, fashion accessories, footwear designs, jewelry designs, animation and gaming, furniture and etc. and many more. In India, the market for 3D printers is still at a nascent stage. However, it offers huge growth opportunities in the coming years. With initiatives like Make in India, the domestic manufacturing sector is being encouraged. This will automatically play a pivotal role in the growth of local 3D printing industry. Considering benefits associated with 3D printing, various industries in India have already started using or are ready to use 3D printing technology. Therefore, the 3D printing service industry is growing at a good pace, but the 3D printing manufacturing sector will need a strong boost. At present, India primarily imports 3D printers from countries such as China, the US, and the Germany. However, with government initiatives to boost domestic manufacturing, many local players are expected to emerge compared to global 3D printer manufacturers. Indian players are yet to establish their brands and lack volumes. However, in the last few years, a significant number of companies in India have come forward to explore this segment. 5 years ago, there were almost no companies in this industry. This has now increased to 5 to 7 companies. People are getting easy access to 3D printers and printing technologies, and market expectations are high. This huge market opportunity is attributed to factors like ease of development of customized products, ability to reduce overall manufacturing cost, and government investment in 3D printing projects for the developments and deployment of the technology. According to 6W Research, the 3D printing technologies market in India is projected to touch $79 million by 2021. The thrust on domestic production, demand for lean manufacturing, and increasing penetration across various applications, coupled with Make in India campaign, will spur the 3D printing market in India. India is an attractive hub for foreign investment in the 3D printing technologies. Several foreign firms operating in the 3D printing industry have set up or are looking to establish or expand their bases in the country. In fact, some have already established their base in India. Some of the major foreign players that have established their base in India include Stratasys, one of the largest 3D printing companies in the world. So the other foreign players like Renishaw PLC, US are also within the reach of Indian buyers and Indian manufacturers. A global leader in the field of industrial 3D printing, US has recently announced its expansion plans in India. US announces leadership movement and expansions in Asia Pacific. 3D printing in India is still emerging fast. However, the country's 3D printing industry is still at nascent stage. When compared with other countries of North America and Europe, 3D printing in India will grow into a full-fledged industry only when the technology will increase its share in the manufacturing sector. Again, I have emboldened the manufacturing sector because today I will discuss about the implications of 3D printing in manufacturing sector and automobile sector. The manufacturing sector of the country is one of the fastest growing sector. In fact, it has a net worth of $311.6 billion in 2016-17, and it has the potential to reach a whopping $1 trillion by the year 2025. This is the report of Indian Brand Equity Foundation, IBF, 2018 January. So 3D printers offer huge cost and time reductions in certain industrial applications while providing better accuracy compared to conventional manufacturing processes. This in turn helps SMEs, small and medium entrepreneurs, and startups, SMEs and startups to reduce their cost of production and enables large companies to make products cheaper, faster, and better. With rapid advancement in material composition, such as the emerging use cases of polymers and metals, additive manufacturing is evolving from a prototyping tool to a functional part of fabrication. New materials, shorter lead times, and innovative finishes while adhering to standards FDA, ASTM, and ISO. These are the main standards that control any industry all over world. FDA's food allocation, SDA's food standards body, associate body, ASTM American Standards of Testing and Materials, and ISO International Organization of Standardization. These are the three main bodies that govern all the processes all over the globe, are enabling the technology to be integrated with manufacturing processes. So this was all goodies and all goodness about the future prospects of 3D printing that we are going to see, and the market share and the money involved and all other activities that are related with 3D printing. So the finance would come and we'd see a huge rise in the market of 3D printing. Now, we have to move a little earlier. So I would be moving to 2014. In 2014, there were many reports, financial analysis and surveys that would say, I have taken only 4, although there are many that I have compared at that time. So there are many, but I have compiled only 4. One is Professional Global Incorporate US. They say in the year 2014 that the current money, the current finance evaluation of the 3D printing is about $7.6 US, and it would be $7.6 billion by a compounded annual growth rate of 20.4% by the year 2020. That means in the year 2014, all these predictions were about the year 2020. They all, Professional Global Incorporates, then Grandview Research Incorporate, then Deloitte Insight Global Research, then Orbis Research. These 4 are important financial institutions or financial analysts as far as global finance is concerned. So all these predicted in 2014 that the 3D printing market would reach by 7.6 billion, 8 to 11 billion, 2.7 to 3 billion, 2.8 to 5 billion, with a compounded annual growth rate of 20.4%, 20%, 12.5% compounding. That means by the end of the 2021, it would be 12.5 compounding, 12.5 doubled, 25, then 50, then 100, then 200. This way, the Deloitte Insight Global Research told about the growth of the 3D printing finance. And Orbis Research also did not give any compound annual growth rate, but they predicted that the market of 3D printing would reach in the range of $2.8 to $5 billion. But by the year 2020, when we again talked about, and they took all their reports, and it was established that the compounded annual growth rate was about 12% only. So they predicted a huge CAGR, but it could not be achieved. So this was the year 2014 when they predicted, and now we can say that by the end of the year 2020, it has only achieved 12% compound annual growth rate. So my concern is, with these findings of this analysis,
Sir,
there are points.
Imran sir, your slide is not visible. Now visible. Now visible. Again, after doing a full screen, it is not visible. Now visible.
Sir, only cursor is visible.
अभी तक कोई स्लाइड नहीं दिखी है।
नहीं, अभी प्रॉब्लम आई है सर। अभी कर्सर भी शो नहीं हो रहा है, बीच बीच में।
अभी तक दिख रही है।
अब आ रही है सर।
अब आ रही है। इनफैक्ट गूगल मीट पे जब भी हम शेयर करते हैं तो ये प्रॉब्लम आती है। चला गया होगा।
अब नहीं आ रही सर, अब शो नहीं हो रही है। अब हो रही है।
Don't do the full screen. Continue as it is.
Yes.
Yeah. Okay, sir.
Okay, so with these findings of this analysis, there are points to ponder. That means we have to think about the reports that we have earlier seen in 2014, and now we have to come to the points. We have to think about the points that with the exponential growth on its sleeve, why 3D printing technologies failed to surpass or even touch the landmark set up by the reliable surveys and financial reports. Number one, this is the most curious point that we have to think, that I was thinking about. When a huge market and a huge success and a growth rate was expected in the year 2014, so why we could not achieve the projected data, not let it go, not even we could touch, not even we could reach near about the target value. So first thing is that why we could not reach the target value, or why could not we could reach near the target value. Then although everyone has been saying a lot of good things about 3D printing, and a lot of good things and about the easiness, about do-it-yourself technology, number of things are told about 3D printing, number of good aspects, but is it really a contender to conventional or CNC machining, or a serious contender, or can it replace to the conventional machining or CNC machining? That is the second point, and that's about we have to think, and we would be answering and we would be focusing on these points that we have to that we have concluded. Now, as said, there is no analysis or data available on the applicability of 3D printing as a replacement of machining. So that is also an area of focus. That is also an area of research that we have to take care, and definitely some researchers will get up to find to analyze why 3D printing cannot replace, or is there any suitability between 3D printing and the conventional and CNC machining. But
again, not visible.
Not visible.
Yeah. Visible now. Visible.
Sir,
Sir, I think there is a problem when you do full screen with the presentation, sir.
Okay, but this time I am not giving full screen.
तब ठीक चल रहा है सर.
Okay.
Now okay.
फुल स्क्रीन में प्रॉब्लम है. अब फिर चला गया है सर.
Okay.
अब आ गया.
Now, went.
गया सर, went. Yeah, now visible.
Okay. I am not going to give it full screen.
Okay, sir.
So these are the points to think about, and these are the points that we have to collectively think about, and we have to stand up and we have to do a lot of research while finding the answer of these queries. But many industry insiders say that 3D printing can't pose any threat to conventional machining as far as functional parts are concerned. Functional parts, that means a few industrialists have told that 3D printing is not capable of replacing the conventional machining and CNC machining. So as far as functional parts manufacturing is concerned, and functional parts are like components that are actually involved in some engineering functionalities, like dynamic system, like you take any, it could be a gear, or it could be a piston connecting rod, or piston anything. Okay, so at the same time, automobile manufacturers and industrial manufacturers still don't see any potential in these technologies called 3D printing technologies. So this is the point that we have to think about. So why these people, industrial manufacturers and automobile manufacturers, are not taking any interest in 3D printing technologies, and replacement of machining processes with the additive manufacturing is a distant dream. So the conclusion of this 3D printing introduction is that replacement of machining processes with the additive manufacturing is a distant dream. And this is the true reality beyond all the good things said about 3D printing. So now I would be discussing the two aspects I have shown. One is the growth rate, the money involved, the finance involved, the technologies involved in 3D printing, and but my concern is the manufacturers and core manufacturers, industrial manufacturers, and automobile manufacturers, why they have not taken this 3D printing technology seriously, and why they are why it failed, why these technologies failed to impress them and to replace the conventional machining or CNC machining by 3D printing technologies. So I'll be coming to that later on, but before that, let me discuss about 3D printing technologies. I will be slightly discussing because since yesterday we are having a lot of talks about 3D printing technologies, and all the basic concepts are clear there, have been cleared by the expert speakers. But this time I'd be giving a slight introduction to the 3D printing technologies. Is additive manufacturing technology. It is called also called additive manufacturing technology, and in this technology, material is added bit by bit, as contrast in contrast to the deductive manufacturing technologies. In deductive manufacturing technologies, we remove material bit by bit, like we do in lathe machine or shaper or drilling machine. There we remove material bit by bit in the form of chips, and the final shape and size is achieved. But contrary to that, we add material in layers and we make the final shape and desired shape and size. The important thing is that all materials can be processed by 3D printing technologies. Hence, additive manufacturing has got a wide range of applications over conventional manufacturing. Almost all the materials can be processed. Hence, this is the advantage of the 3D printing that, or additive manufacturing, that all materials can be processed, and hence it has got a wide range of application over conventional manufacturing. This is the diagram. This is the classification of additive manufacturing. Basically, we have three types of three types of manufacturing processes. One are jetting method, another laser method, and third is laminated method. Okay, so in jetting method, a certain jet is responsible for manufacturing of the product, whereas in laser method, a laser is scanned, a laser is moved to the profile or path of the part that is to be made. And in lamination method, like we do while making different types of hard bounds, in lamination process, we put layer by layer by sticking certain glue or by adding certain binder between the layers. So these are three main processes, and I'm not going to discuss more about this because this has already been clarified since yesterday. So in jetting method, we have glue based, thermal based, liquid based. In laser, we have liquid laser, and lamination, we have glue lamination. So these are the 3D printing technologies. Fuse deposition modeling, or triple F, also called fuse filament fabrication, then stereolithography, then SLS and DMLS, laminated object modeling, and then we have, this is the basic classification of 3D printing technologies. Then my section the next section of my talk is on what process, on what standards the material is selected. So because in the starting of the talk I told that my focus is the core industry or industrial manufacturers or automobile manufacturers. So keeping the track with this point of origin, we will be discussing the selection of material, how the material is selected for a particular part or a particular component. So these are the mechanical properties, and on these mechanical properties, based on these mechanical properties, we select a material. So this is related with the basic design process that we have to understand first, and then only we'll be able to come to the later on to other discussions. Okay, so first thing is we have to find appropriate mechanical properties for our components or the parts. So if we have, first of all, we have to find a strength. So strength are two types of, there are, one is before failure and one other is after fracture and before fracture. So, or we can say ultimate tensile strength, the maximum before the peak and after the peak. So, strength is three types, basic three types: compressive strength, shear strength, and tensile strength. Another types of strength is elastic strength, ultimate strength, and yield strength. So all these are very much associated or related with the parts, but the functional parts that are used in the industry or that are used in several machineries and automobiles. So we have to look first of all on the strength and precisely compressive, shear, and tensile strength. Also elastic parts are, elastic strength is very much of values. First of all, we have to look after the strength. This is the basic criteria. If we make a gear or make a handle and that doesn't have good compressive strength or good tensile strength, it is going to fail. Although other parameters it could meet, but since it doesn't have the required strength, it won't be able to perform its functionality at the best. So first of all, first property that we expect from any product or from any material for the suitable to be for suitability of the part is strength. Then comes next is the fatigue and then brittleness. Fatigue, as we know, is the amount of cycles or the time for that material can work. Okay, so fatigue strength is cyclic loading, is related with the cyclic loading and unloading, and because of this cyclic loading and unloading, there is a stress development and this leads to failure. So this phenomenon is called fatigue, and this fatigue strength is also of utmost important. Then we have brittleness. Brittleness, the material breaks all of a sudden without giving any sign of breakage, is called brittleness. So brittleness, these are the mechanical properties that are related with the functional parts or core parts that are used in industry or automobiles and other machine components. Okay. So now the other mechanical properties that are associated with the part is stiffness, hardness. These are also very much related with the functionality, with the or component. It must be stiffer, it must have hardness, it must be hard. Hardness is defined as the material's ability to scratch, to resist scratch or indentation or penetration. And stiffness is the little deformation that takes during loading and unloading. Then we have toughness. Toughness is defined as the material's capacity to withstand elastic and plastic deformation without failure. And embrittlement, the result of metal losing its ductility and becoming brittle due to chemical or physical changes. Then last is the homogeneity. That means while going through the process, while working the functional parts, they must remain homogeneous all the times, because stress concentration leads to failure of the component, and we would not like to the material to fail. So we have to keep the material homogeneous all the time in what however it is working all the times. So homogeneity is the last mechanical property that is required for functional parts. Then how this was about how materials are selected for a certain process. Then next is how manufacturing processes are selected. On what basis the manufacturing processes are selected? First is the manufacturing process must be suitable for accomplishment of design data. That means from the design data, whatever design department, whatever data we have received for any particular product, we must select a process, manufacturing process that accomplish or the fulfill the demands of design. The data provided by design department. Another is geometric dimensioning and tolerances. GDT, geometric dimensioning, that means exactly shape and size the design department has given to us, keeping the dimensions and tolerances within the tolerances. And most important is the mechanical properties. Mechanical properties, the process that we are selecting must be capable enough of providing all the mechanical properties that are expected from the part or component. Then availability is of the process. Of course, if we have two processes and for example drilling, producing a hole by drilling machine and producing a hole by lathe machine, so would be going for the drill, because in that way it would be easy to produce a hole by drilling machine. Availability and ease of the process, and last one is the economy. After we fulfill all the technical capabilities, technical compensations, we go for the economy. If we are given with the two processes A and B, and A is more economic and A consumes lesser money, so we would be going with the A. So economy is the last. So this is the selection of the process. Now, quality issues. What are the quality issues? Although my topic of the talk is quality issues in 3D printing, I started from the market survey. Now I am coming to the quality issues that are found. And because of these quality issues in 3D printing, the 3D printing, these technologies have not gained much access into the core manufacturing in core sector. So what are the quality issues? As I told, that what are the design expectations? So these are the design expectations. I told we are expecting the strength, we are expecting the fatigue strength or fatigue resistance, we are expecting the brittleness to we are expecting the brittleness not to come over, we are expecting the stiffness, we are expecting the hardness, we are expecting the toughness, we are expecting the embrittlement, to resist embrittlement. So these are the homogeneity. These are the properties that we are expecting from our process. So first thing is functionality. So mechanical properties, C part, as we discussed, these are the mechanical properties. We are selecting a process on the basis of that provides us good mechanical properties, and then availability of the process, and then economy. Okay, so we are coming to what are the quality issues. Quality issues, first of all, the most important is the functionality. We are not getting the design data from the 3D printing technologies as it is expected. So, for example, you produce a part from 3D printing, and the same metal you process on CNC machine, CNC lathe or CNC turning. The CNC lathe or CNC technologies part produced would be giving you more strength, more compatibility, and other relevant data. So another is surface finish. Of course, 3D printing cannot match the surface finish provided by the conventional machining and CNC machining. Then third one is dimensional accuracy. This part is also of utmost important, and if we have to design a part that that of more precision and more accurate part, but in the 3D printing technologies, we are not capable of providing that much dimensional accuracy as in the conventional and CNC machining. And last one is the cost. Cost is the last one. So 3D printing gives us benefit on the D section, on the D point. That means 3D parts, 3D printed parts, parts produced by 3D printing technologies have a lesser cost as compared to the conventional machining. But the first three technical parts would not let the 3D printing to come to the core manufacturing. So these are the quality issues in 3D printing, and this is the Ishikawa diagram or fish and bone diagram that basically depicts what are the causes and how they result in poor quality. So we have man, a large or complicated 3 object was printed. So because of human errors, because of machine errors, because of materials, and because of methods, the poor quality of 3D printed part is produced. So we have to take all these factors and all these parameters into consideration while overcoming the problems, overcoming the quality issues in 3D printing, so that if we have to make compatible with the modern industry and core manufacturers and automobile sector. So we have to take all these points into consideration. I hope new researchers who are joining this FDP would focus on the core sector and manufacturers, automobile manufacturers and machine manufacturers specifically, to overcome these problems, and so that 3D printing process is takes its share of modern technologies and takes its share in core manufacturing also. So these are the quality issues and their causes. So conclusions of this talk is 3DP has good market scope in India. It has huge potential in every sector of manufacturing. It is not being applied in core manufacturing sector. It is established by now that the 3D printing is not being applied in core manufacturing, and the reason is poor mechanical properties and the metal 3D printing part produces. So this is the conclusion of this talk, and also the other points are inaccurate dimensioning. Precise research is required. As I told, young researchers will come forward to look into this aspect, because other fields, number of researchers are working and analyzing and deeply working into the depth all other fields, but few people are working in the core sector and core mechanical manufacturing systems. So why, what are the causes, and why these causes, and how these causes can be prevented, and how the 3D manufacturing can be implemented to the core manufacturing sector also. Also, we have to establish a functional relationship between process parameters and performance measures, because everything is related with the process parameter. Process parameter are the inputs that are given at the time of manufacturing, and hence they affect any slight movement, any slight wrong feed given to the process parameter would lead to the bad quality products. So a lot of research is being done in this area, and number of researchers are working. At the same time, I would request to researchers joining here to explore the applicability of 3D printing in the core sector and manufacturing sector. I hope I have motivated and gave the correct idea of research as far as core sector is concerned. So this is the biblio that I used, and these are the references that I have used in my talk. Some major researchers. Thank you. Now I would invite you to put up your queries regarding the application of 3D printing in core sectors. So you can talk to me now.
Anybody want to ask anything?
Participants are encouraged to ask their queries, to put up their queries. Deepak sir. Deepak sir, you may put up your queries.
Yes, if anybody want to ask anything,
You can
then
also ask. Deepak sir, you can also ask.
so actually here we are working on materials used in FDM machine.
Yes, sir. Yes, sir.
So can peak be used in FDM? Peak
Peak.
material.
Yes, that's it. Yes, yes. peak material.
So actually, it requires 450 degrees Celsius temperature
Agreed.
to melt. But at present, there is no nozzle available in the market right now to.
Accommodate that much of heat.
Yeah.
Actually, sir, the if you take the peak, we are not. This is called fuse deposition modeling or
Yeah.
fuse fabrication filament. That means we don't have to melt the whole of the filament or whole of the peak, but we have to we have to bring the outer crust of the filament at slightly molten form. Otherwise, it will not stick. So what we do, we can create a specific peak for this, and if you ask the manufacturers of the filament, so they will create a specific filament that has that has outer crust or the exterior of the filament melting at slightly lower level. So you can ask your manufacturers to accommodate this type of filament.
Okay. Thank you, sir. Thank you. Yes, one Ravi Kumar is asking how to control surface quality.
Surface quality of produced part
How to control the surface quality of the object made
object.
with the help of FDM within a time period.
Surface quality, this basically you see the phenomena is that the filament, the outer crust of the filament is slightly elevated and it comes into molten form. So what is the problem when the outer crust or the crust of the filament is not fully in fused form? It would not stick together at micro level. So what we have to do, we have to increase the temperature of the nozzle so that when the when the filament is coming out of this nozzle injector, it is at an elevated temperature and completely joins with the adjacent layer. So for that we have to increase the temperature of this injector nozzle. About 22 parameters are and 22 parameters are responsible for the quality of the fuse triple F or fuse deposition modeling method. So in 22 parameters, we have to take care of every parameter, and we have many open software sources like Cura. So you see, there is very precision. They are working in very precise range. So you can take help of those softwares that are freely available. Cooling time also increases. How to control surface quality of object made with the help of FDM within time period. Cooling time also increases. Of course, it will increase. Once you give the temperature, once you produce the part at elevated temperature, it will take more time to get in normal time or solidification cooling time. So it will have more solidification time. Cooling time will also increase. Of course, it will increase.
One participant is asking about the raster angle. What will be the effect of raster angle on the printed part?
Yes. Raster angle is basically related with the orientation of the printing. So print, if you print like this or like this, it will not produce as much strength as at an angle. Why it is that so? Because you see, it will have two components, one acting in when the header or injector nozzle is moving inclined or in tapered form in along the slope, then it has two components. One component is in X direction, another in Y direction. So this will have a combined effect. So inclined injector will have a combined effect of all these two. So in that case, either you are taking X or taking Y. So in that case, either it is X or Y, but in that case, it is coming along the hypotenuse. It will have combined effect of lateral and transducinal, both the case. So this will affect more, produce more strength. Raster angle having value of 45 degree will have more strength than any other angle. How to design quality of composite material polymer in 3D printing. Okay. How to design quality of composite material polymer in 3D printing, composite with graphene. Actually, Kaushik, I could not understand your question. How to design quality of composite material polymer in 3D printing? Okay, so I got. So you're talking about the parameters, the input parameters that would produce the optimum level of the best level. So composite and with graphene, there is no as such solution of this problem that you are talking about, that you have to experiment yourself and you have to set up different parameters, different level of parameters, and then you have to test. So this is going to be a full-fledged research and full-fledged analysis. So there you have to change. There you have to take different levels of parameters and then produce the part and testify, and then only your question can be answered. So this is there is not a direct answer of this question as such. Composite with graphene. This is a matter of research, of course. Welcome. Anybody else wanted to have any query? Please ask.
Yes, one question is by Mohit Beniwal. 3D printing used in present scenario for any automobile industry?
3D printing is being used in many parts of automobiles, like car seat belts we are having, and many other, but they are not functional parts. My concern is about the materiality of the 3D printing in functional parts. Functional parts means that perform certain specific job, like like I discussed about the gears, I discussed about the crankshafts, etc. So these are working shafts and functional parts and products. So still there is no any indication. I have not seen any indication in the industry or in the research that they are going to use 3D printing for any functional part. They are using many technologies. They are using 3D printing for producing many parts, like chamfers and like holders, and I told just about and I told about the can we use PLA extracted from biomaterials. I will discuss, and also seat belts and many clamps are there, many holders are there. All these are non-functional parts, and they have found they are basically small parts, and they are basically non-functional parts. They don't have to go through much of the strain, and much of the properties are required from them. So for that, 3D printing is being used in automobile industry. Mohit, hope I answered your question. Mohit, you got your answer?
Yes, Imran sir. Now next question is from Sergius Joe. Which 3D printer would you suggest for manufacturing composite materials?
FDM. Composite materials are best used with FDM, fuse deposition modeling, or triple F, fuse filament fabrication. So these printers utilize PLA, polylactic acid, at a higher level. Uh, and PLA may be extracted from biomaterials, as well as PLA can be extracted from the non-natural resources. So polylactic acid is the best filament available, and it can be used with FDM printer or triple F, fuse filament fabrication. Sergius, is it clear? I have gone through many variants of flash forged dual extruder, more useful than single extruder. So, Sergius, is it information or is it a question?
It's a question, sir, actually.
Okay. So, what you wanted to know? I have gone through many variants of flash
Yeah,
forged.
actually, we are about to purchase a 3D printer.
Mhm.
So, we are planning it for consultancy work, actually.
Mhm.
So, I've gone through some variants of Flash Forge, and it is the availability is from 15,000 to maximum of 3.5 lakhs.
Yes,
So,
yes.
which printer would you suggest, sir? So, for a consultancy purpose, which printer would be better for us?
As far as time is not a factor, I would suggest a single intruder, single extruder or single nozzle injector printer for you, because when we are giving three layers, when we are giving three injectors are moving at a time. So obviously they would be distributing the space and uh, space and the resources. So what I would suggest, that if you use a single extruder or single nozzle injector printer, that would be good for the, as far as research or consultancy is concerned. But if you are making parts, or where the time is a factor, you have to make a product within certain time. So there you can use multi extruder printers. But in this system, you need a single extruder. What I would suggest.
Sir, actually, from my research, I have identified the Creator Pro model, actually.
Okay.
So, do you have any idea in this regard in Creator Pro? Flash Forge Creator Pro.
Flash forged period.
So, have you used it actually?
Yes, yes, I've used. But which model you are talking about, I have not seen. I have not worked on that. Flash Forge, iDual extruder I have seen, and Flash Forge, uh, Multi Pro I have used.
Okay.
They are very good printers. They have very good printers, and they have very precise, accurate precision, accuracy, as well as quality of the products is very good.
So, can I share a small image actually that the one of the customer who bought this Flash Forge, they said that dual extruder has a small problem like offsetting. So he
Okay.
has shared me the image also. I'll
Okay.
just present my screen now.
Okay.
So,
Also, sir, yes, also
okay.
I'm giving you the number and other participants. So they have any queries related to functionality of the 3D printing or printers. So you can, this is my WhatsApp number. So you can take 90693604000. I have written in the chat box. So you can discuss it with me at
Okay, sir.
WhatsApp or at phone.
Okay, so can you see the image actually?
I could not see. You have shared?
Yeah, I have shared my screen, sir.
No, first of all, I have, okay. First of all, I have stopped. Just a moment. Yes, yes, I can see it now.
So we are using two colors actually of PLA materials actually.
That's it.
But the second extruder, when it's coming, he said that the first beginning of the printing itself, it went on offsetting. So they have claimed the customer, the seller, but the seller was just giving an instruction that it is what the problem of dual extruder we cannot rectify. So is it so, or else there is something else the seller is hiding from us?
Actually, there is a crucial leveling of these printers. The problem with these printers is that we have to level precisely, and within the 15 microns range or 50 microns range, you have to level this. So, what I think that there could be a leveling problem, as well as there could be two problems. One is horizontal and one is vertical. So there could be a problem in leveling of the printer as well, because these two extruders are not moving at the same angle. So there could be a problem in horizontal leveling, or there could be a problem in vertical leveling. So you have to check the leveling, and for me it's a difference. It's only because of the leveling that the problem is occurring like this. There is no they are offsetting, and there is a no match in the exterior shapes of the two colored produced. So any other problem, I don't suppose. They will stick together. They're very good printers, and they will stick together at precision level. So you have to check the levels in both the cases, in horizontal and vertical level as well.
Okay, sir. Okay, okay.
How can we make waste materials like plastics and materials to be used again as filament? By that I mean processes. Plastics, any material. Actually, Ashu, we have two types of plastics. One are thermosetting plastics, and we have thermoplastics. So, thermosetting plastics are non-reusable, whereas thermoplastics can be reused. So the whole problem with the universe is right now we are having this problem that we are having we cannot completely decompose. We cannot completely decompose the plastics that are not reusable. So there are many technologies working on it, and let's see what exactly comes out. So once we are capable of recycling the thermosetting plastics, we would be able to reuse it as a filament. How can we make waste materials like plastics, any material, to be used again as filament? By that I mean processes. Ashu, is that clear? Hope I have answered your question.
Thank you so much, sir, for the interesting conversation. I would like to take pride in saying that Dr. Siraj shared knowledgeable presentation. It was a great session. We learned about the quality features of the 3D printing. Today was the last session. Now we will meet tomorrow morning in the 7th session with Dr. Mir Irfan Ul Haq. Have a good day. Stay safe. Thank you so much.
Thank you. Welcome.